In this video, we are going to simplify algebraic expressions with adding and subtracting. Here we have a few coins. Do you agree that we have 1, 2, 3, 4, 5 coins and that I can say you have 5 rand? This is definitely not true because the value of a 5 rand is more than that of a 2 rand. The correct way of approaching this is to say that we have 2 5 rand coins, which means 2 times 5. And to this, we need to add the 3 2 rand coins that we have, which means we add 3 times 2. If we now simplify, this will be 10 rand plus another 6 rand. So in total, I actually have 16 rand. This same approach can be used in algebra. Here we had 2 5 rand coins. And in algebra, we can also say 2 of a specific type of coin. To this, we added 3 2 rand coins. And because a 2 rand coin has a different value, we could have said 3 times a different type of coin. So in algebra, different letters represent different values. If we did not know the value of each of the coins, this would have been as far as we could go in algebra. We could not say that this is now 5 coins. But as soon as we are given the actual values of the coins, we can substitute that and then determine the correct amount. So when it now comes to adding and subtracting in algebra, it is very important to know that you can only add and subtract like terms. Like terms are terms of which the variables or the letters are exactly the same. Example 1. Simplify. In A, we have 3 terms because, as you know, terms are separated by pluses and minuses. Here, all 3 terms have a variable of x, which means they are like terms and can be added up. To add up, we need to determine how many of these variables we have, and for that we focus on the coefficient of each term. The first term's coefficient is 6, the second term's coefficient is plus 3, and the third term's coefficient is minus 5. So here we will have 6 plus 3, which is 9, and 9 minus 5 will give us 4. So here we have 4 x's in total. So when you are adding and subtracting, you may only add and subtract like terms, and to do that you focus on the coefficients and add them up. The variable never changes when adding and subtracting. In question B, we once again have 3 terms. But this time, only the first 2 are like terms, because the third term has a y for a variable. So when I'm going to add and subtract, I will only focus on the coefficients of the first 2 terms, and that means I will take 3 and subtract 8. Therefore, we will have minus 5 of the x's. The 2y is added to this, and this is my final answer. Example 2. Simplify. Here we now have 4 terms, and the first term as well as the third term both have a variable of x squared and are like terms. The second term has an x, and also the fourth term, so they are like terms. When adding up, we now know that the variable always stays the same. So we need to determine how many x squares we have and how many x's we have. For the x squares, we are going to have a look at the coefficients of 25 minus 14, and that means we will have 11 x squares. And for our x's, we will have the coefficient minus 7 and then minus 3 more. So on my number line, if I am at minus 7 and I move 3 more in the negative direction, I will have minus 10 x's. This will be our final answer because these two terms are not like terms. In question B, we now have 5 terms, and first of all, we once again need to identify the like terms. Our first term has a variable of ab squared, and even though the second term looks similar, they are not like terms because the second term now has a squared b. In the first term, we have a times b squared, which is b times b. And in the second term, we have a squared, which is a times b. The third term is now a like term of the second term because both of them have a squared b. In the fourth term, we now have b squared times a. And even though it doesn't immediately look similar to our first term, from the first video you already know that we prefer to write in alphabetical order, which means this is minus 2ab squared, which are the same variables we have in our first term, so they are like terms. The fifth term is also ab squared, and so also a like term with the first term. So we need to determine how many ab squares we have and how many a squares b we have. For that, we focus on our coefficients again. So we start with 12, and from that we need to subtract 2, which will give us 10, and then add 5 again to end with 15 ab squares. And then we start off with plus 6 and add 4 more to end with plus 10 a squared b's.